So this is our third video on Edmodo that you'll be able to find. I'm just asking you to graph it, and there's actual 4 pieces to this thing. There's 1, 2, 3, 4, 4 pieces all put together. So let's take a look at this first one and imagine it being y equals -1. Well, that would simply be a horizontal line going through the y equals -1 value, right? Now we do want to show that we want to look at the values that are less than -4. So the x value of -4 is right here. So you're really just seeing a little tiny piece of this thing, which would be right here. Does that make sense? Because the line y equals -1 is down here, it's infinite, but they only want to see the pieces of that, or the piece of that line that's less than -4. So -4 is right here, so we're only seeing the left-hand side of it. I hope that makes sense. Let's take a look at this next one. This next one's a parabola, and if you think about the parabola, the parent graph of a parabola, it's at 0, 0, and then it goes 1, 1, 2, 4. So it's really a parabola that looks like this, has a vertex 0, 0, the parent graph. However, this does have an H shift, and what does that mean? That it goes 2 to the left in this case, because the H, you have to think opposite, remember? So your vertex that would have been right here, your parabola that would have been right there with the vertex right here, is now going to be going 2 to the right, to the left, 2 to the left, because you think opposite. Instead of +2, it's -2, and here's your new vertex. So let me actually put that in right here. And then we know that this parabola is opening up because it has the a value of 1. We know the pattern is 1, 1, 2, 4, and 3, 9. So we could go through this. I am going to, but before I do that, I want to think about the window. The window's from -4 all the way to -1. So yeah, I want to go 1, 1 and get right here, but I'm not going to go further than that. I'm not going to go 2, 4. I only go 1, 1. And to the left, I really go 1, 1, 2, 1, 2, 3, 4. So we really do have this graph. Now, if we take a look at the inequality, both of them are or equals 2's, so they are both solid dots right here. And I stop right there. Why am I stopping right there? Because it's telling me from -4 to -1. -4 is right here, and -1's over here. So it's kind of just this piece of the parabola. I mean, if I showed the full parabola, it would go up like this, right? But I don't want to show that full parabola. We stop right there. I hope that makes sense. Let's move on to the next piece right here. That next piece is a square root function, and it does have both an h and a k shift. So if I wanted to think about that square root function, it'd be best to think of the parent graph of that square root function. So my parent graph of that square root function would be y equals the square root of x. And then you could also even think about an xy table and think about numbers that work nicely in there. So like 0, 0, because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And those 3 coordinates will give you enough to get your parent graph. So I want to show my parent graph in blue. Here's 0, 0, 1, 1, 4, 2. 4 and 2 is right there. So we have those 3 blue dots that give us the parent graph of the square root function. But I am going to move those blue dots 1 unit to the left and 1 unit down. It has an h value of -1 and a k value of -1. So I want to take each of these blue dots and move them 1 over 1 down, 1 over 1 down, 1 over 1 down. And I want to do those dots in red. But the first dot, 1 over 1 down is right here. Whoops, kind of right there somewhere. And then the next one, 1 over 1 down is right here. The next one, 1 over 1 down is right there. I hope you guys see those red dots. So anyways, this is my new square root function. And I do want to look at this square root function only from the values of -1, open dot at -1, and closed dot at 3. So open dot at -1, that was this one down here, that's an open dot, and closed dot at 3. And if I connect these 3 dots, I have my square root function. Now we know that square root function, if I were looking at the entire square root function, it would keep going like this forever. right, go in this direction. But since I know I'm only looking at this piece of it between -1 and 3, it stops here with an open dot and it stops here with a closed dot. Now for my final one is a linear function, and we know y equals mx plus b. We know the b value is 3. So this one's going to cross at 3. Let me do this in red. Crosses at 3, and then from that point, I'm going to go down 1 over 1, and 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 down 1 over 1. And that would be my perfectly straight diagonal line for the function y equals -x plus 3. However, we look at the restriction, or the domain of this graph that they want us to look at, and it's saying x is greater than 3. So here's 3. Which way is greater than? To the left or to the right? To the left. I mean, to the right. Yeah, whoops. Greater than is to the right, always. So we are going to go to the right. So we're just going to show, and it's going to be an open dot at 3, and it's going to the right. And that's our final graph, piecewise function graph right there. As you could tell, nothing is connected. 1 piece, 2 pieces, 3 pieces, 4 pieces. All of it is disconnected. Yeah? In other words, it's not fluid. I shouldn't say they're not connected. There is no x value that makes it undefined, because if I told you for the input -5, what would your output be? So for the input -5, you'd go here and your graph is at -1. So for the input -5, your output's -1. Does that make sense? For your input -2, what's your output? 0. For your input -3, what's your, or actually -3, what's your output? 1. For your input -4, what's your output? 4, that's right. For your input 0, what's your output? For your input 3, what's your output? 1. You guys are following me here? So it is continuous. There are no undefined values of x because it is continuous. But what I'm trying to say is, just because you're graphing a piecewise function, it is possible that they visually look disconnected, like there's a gap right here, there's a gap right here, there's a gap right here. But it's still all defined at all x values. Your domain is all real numbers, right? Does that make sense? So how about we take it a step further, like we challenge ourselves here, and let's use the skills that we learned in semester 1 to be able to manipulate what we see here to make it all connected. All right? So in other words, if we take a look down here, I'm asking you to create a new piecewise function by modifying h of x, that's all of this, to make it continuous / connected. So what could we do to this thing to make it all connected? In other words, what would this new, let's call it q of x function, what would the new q of x function be? The q of x piecewise function. Any thoughts? Would you like to move the parabola down so it'll be connected with this one, or do you want to move this one up, or I don't know, what do you guys think? Let's move, I say move the parabola down, right? How many units would I have to move it down so it'll connect with this guy? 2, right? So if I wanted to move this parabola down 1, 2 units, what would I have to do to this parabola over here? In terms of transformations, what needs to happen to this parabola? A k value of -2. -2, because the k is actually taken for what it is. So that first one, or actually that middle one, is going to be with the k value of -2. So as you can see, I have the same function, parentheses x plus 2 to the second power. We just put on a -2, which would cause this vertex to go down 2 units, which would cause this point to go down 2 units, and this point to go down 2 units. So let me actually transfer those, and let me do it in black here. 2 units down would be right there. 2 units down would be right here. 2 units down would be right in that open dot. And that would make it continuous right here. Make sense? Sorry, that's ugly. Maybe I could, let me see if I could fix that. One more time. Oh, and I forgot to bring this point down 2 units, which would be right here. So I'm going down like this, curves up, boom. Still ugly, I apologize. Anyway, so now these guys are connected, that's great. We move the parabola 2 units down by slapping on a k value of -2. What else could we move around? We could move this equation, move it to where? To positive 2, right? If we just had the line positive 2 instead of -1, so we would put that 2 up there instead of the -1. So the first one was -1. Yeah, they gave us a line at the y equals -1, but we changed it to 2, which would make this line be up here at 2. So check it out. I want to put it on there. And now it's continuous. Okay? In other words, it's touching. And how about the last thing that we could do? The last thing that we could do to make the connection right here. We're going to leave this square root function exactly the way it is. But how about the this line? What do I have to do to it to make it connect up there? Do a +1 on your K shift, right? So what line should this, or what equation should this be? Instead of y equals -x plus 3, we're going to make it what? Y equals -x plus 4. That's right, because we're going to add 1 to the K shift, so it's going to move it all up 1. So check this out. If I did put, wait a minute. Let me write my square root function here before I talk about my line. That's disgusting. But for the line, we said it's going to be a -x plus 4. -x plus 4. And that would really change the y-intercept up to 4, and you'd go down 1 over 1, 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 which would connect it right here if you're looking at the values that are greater than 3. By the way, that's our new q of x piecewise function, but we still had to put the same restrictions that it had before. What do I mean by that? That first one that had a -1, it should say if x is less than -4, you're going to do that to the 2. Put if x is less than -4. Like so. And I believe you guys get the idea. Whoa, not connected. So I said I believe you get the idea. You just put the same restrictions on each of them and you'll be done.